so now let's look at the second guided example. It says graph f of x is equal to sine of x over sine of x minus 1 on the interval of 0 to 2 pi. What you can do to get started, would be, so we saved our work, so save it as something memorable, I guess. For this one, I'll just call it rational function. And then that little drop down there allows you to duplicate it. I'm going to call this trig function. So I have a separate file now, and I could just make modifications to it. That's actually one of the reasons why I have you do this, is that you can set up a single Desmos and just modify it rather than reinventing the wheel every time. All right, so we have sine x over sine x minus 1. So you can just type it in. The default setting is radians, so we're good there. All right. I also want to make a statement of what the domain is. All right. So you can see how it's written here. It's inequality notation. It's just you have to put it in the squiggly brackets. All right. So squiggly brackets 0. To get a less than or equal, just do a less than followed by an equal. X less than or equal to 2. To get a pi, just type in pi, and it knows that that means pi. All right, so we have our setup. In terms of the viewing window, we can kind of play around with it, but as long as you see the important stuff on the screen, it's perfectly fine. All right, so I'm looking at an asymptote right around here. It's just a question of if or whether there's anything else going on. All right, so the denominator is degree 1, so there should only be one discontinuity, right? Just any instance in which the sine of x minus 1 is equal to 0. All right, so a little typo here. We have to the location. I would imagine I'm supposed to say we have to find the location. So we create the slider. But our slider now, even though we can probably flesh it out based off decimal values, we certainly don't want to have integer values, right? Because trig, in terms of the angles around a unit circle, they're not integer values, right? There are a few integer values along the way, but primarily not. All right, so I'm going to click on the slider, change my low bound and my upper bound to be consistent with my domain. I'm going to change my step. So you could change it to really anything in terms of pi. It's just a question of whether you're actually going to be able to see what that value corresponds to in terms of a decimal. All right, so I'm going to go pi over 12. And the reason I do that is because every value in the unit circle can be counted in increments of pi over 12. Right? So we don't often work with something like specifically pi over 12, but 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4, and so on. So we'll get some extra stuff there, but we're among the extra stuff, we're going to get the stuff that we need. All right, so now I can drag it along, just going from left to right. Add 0, it was 0, so that's good. All right, and just kind of move along the line here. All right, and you see all these values. Now you can animate it if you want. I find sometimes that just goes too fast, right? But you know, that could be something. And you know, as I'm noticing it, I realize that there is a moment where a flash is to undefined. So it's just a matter of finding that. Oh, there it is. Now 1.57, that's equivalent to pi over 2. If you're not sure, what you can do is take that decimal, because it's already got a pi factored into it. So I'll just do it down here. If I take pi and multiply it, if I take the decimal and divide it by pi, it'll give me the fractional coefficient of pi. All right, so this is equivalent to 1/2 pi, or pi over 2. All right, so you got the ugly decimal, you can divide out the irrational number pi, and that'll leave you with something that should be recognizable. It may not be perfect, but it should be recognizable. So this is equivalent to 1/2, so I bring the pi back in, and I get my value. So I could do it like this, 1/2 pi, confirming that gives me the same decimal, so now I'm pretty good with that. All right, so that indicates, based off of what we're seeing in the diagram, it looks like that's the location of the asymptote. So since there's only one, I don't need the second table. Actually, I don't need anything more than the first table. So I'll just wipe these out. We have a vertical asymptote when x is equal. Now, when you use the note feature, it's kind of annoying because when you type pi, it just stays as pi, but that's something we can live with. There is no hole in the graph, so I'd wipe that out, right? So pi over 2 would be the location of the vertical asymptote. I just need to verify that. I can get rid of this now, right? If this bothers you, you can get rid of all the extra stuff that we don't need. All right, so we're looking at an incremental change from pi over 2. So I'm going to do pi over 2. I'll do a little quick copy on that. And we're just subtracting 3 infinitesimal values, or really just very small values. And let's see. And then just observing the nature of the relationship. I got an extra 1 there that I don't want. All right. So this value right here is trying to say negative infinity. That's -2 with 8 zeros after it. So that's pretty extreme in the negative direction. And then we're going the other way. So pi over 2 plus 0.0001. Same deal. We're looking at something that approximates negative infinity. And then you can just go a little copy paste crazy here, and you should be able to at least get a reasonable table. All right, so it looks like it's approaching negative infinity from the left, from the right, so that justifies the vertical asymptote. And again, I don't need a second table. All right, so this one is actually much shorter, but it's only much shorter because we took the time to do the work for the first guided example. All right, so then same deal, you're creating a share link and submitting it. So you're going to tackle these problems. The first two are very much like guided example 1. The third one is very much like what we just did. All right, and the last one involves a log, but it's still the same principle. All right, so in the end, you should either have 4 share links or really one massive Desmos, but I really don't recommend that. Right, so when you create your share link, for each one, copy it, paste it into Brightspace, and just bear in mind that any edits that you make after you generate a share link, those will not be included in the share. All right, so it's not really a living file. So if I made a substantial change, I would then want to make a new share link to submit on Brightspace.